What if we could harness the power of quantum physics to fuel artificial intelligence? Welcome to the fascinating world of quantum computing and AI. Artificial intelligence, or AI as it's commonly known, is no longer a concept consigned to the realm of science fiction. It's here, it's now, and it's an integral part of our everyday lives. From the search engines that help us navigate the vast expanses of the internet, to the personal assistants in our smartphones, AI is everywhere. But how do we define AI? Simply put, artificial intelligence refers to intelligent machines that can perform tasks without human intervention. These tasks could be anything from recognizing speech, to making decisions, to visual perception, and even translating languages. On the other hand, we have quantum computing. Now, this might sound like a term straight out of a sci-fi movie, but it's very real, and it's set to revolutionize the world of technology. Quantum computing is an area of study that's focused on developing computer technology based on the principles of quantum theory. Quantum theory explains the nature and behavior of energy and matter on the quantum, or atomic and subatomic level. It's a complex and often counterintuitive field, but its potential is limitless. Quantum computers aren't just faster than our current computers, they work in a fundamentally different way. While traditional computers use bits, which can either be zeros or ones, quantum computers use quantum bits or qubits. These qubits can be both 0 and 1 at the same time, thanks to a quantum quirk known as superposition. This allows quantum computers to process a vast number of computations simultaneously. The intersection of AI and quantum computing is where things get really interesting. Imagine an AI system that can learn and adapt at an unprecedented rate, powered by the almost unimaginable processing power of a quantum computer. The possibilities are as vast as they are exciting. This is just the tip of the iceberg. As we delve deeper, the intersection of these two fields will reveal a world of possibilities. Artificial intelligence, a complex term, but what does it really mean? Well, think of it as teaching a machine to mimic human behavior. It's like giving a computer the ability to learn, reason, perceive, infer, communicate, and make decisions. But let's break it down further. At the heart of AI is a concept called machine learning. It's a bit like teaching a toddler. You show them a few examples, and they learn from these experiences. Only in this case, the toddler is a computer algorithm. You feed it data, lots of data, and over time, it starts to recognize patterns and make predictions. Just like a toddler learning to identify a dog from a cat, the algorithm learns to distinguish spam email from legitimate ones, for instance. Now imagine trying to replicate the human brain's structure in a machine. That's where neural networks come in. These are complex models designed to mimic our brain's architecture with layers of interconnected nodes, or neurons. Each neuron takes in some input, processes it, and passes it on. It's like a game of telephone, but instead of a whispered message getting garbled, it's refined, honed, and clarified. And where can we see AI in action? It's everywhere. When you ask your voice assistant for the weather forecast, that's AI. When your music app suggests a new song based on your listening habits, that's AI too. It's in the recommendation systems that suggest what product you might like to buy next, in the face recognition software that tags your friends in photos, and even in the self-driving cars that are becoming more commonplace. So when you think about it, AI is not some distant, futuristic concept. It's here, right now, woven into the fabric of our everyday lives. It's learning from us, adapting to us, and in many ways making our lives easier. AI is not just a future fantasy. It's happening now, shaping our lives in ways we often don't even realize. Quantum computing, a term that sounds like it's straight out of a sci-fi movie. But what is it exactly? Let's dive into this fascinating world that's not as far out of reach as you might think. Imagine a switch that's either on or off. That's how traditional computing works, with bits that are either zeros or ones. Now imagine a switch that can be both on and off at the same time. That's a quantum bit, or qubit, the fundamental unit of quantum computing. While a traditional bit can represent two states, a qubit can represent an infinite number of states. This is due to a quantum principle called superposition. Superposition is a bit like being in two places at once. It's the idea that a quantum system, like a qubit, can exist in multiple states simultaneously. This is what allows quantum computers to process a vast amount of information all at once. Now let's bring in another concept, entanglement. It's a bit like having two coins that always land on the same side, no matter how far apart they are. In the quantum world, if you know the state of one particle, you automatically know the state of another, no matter the distance between them. This strange but essential phenomenon allows quantum computers to perform complex calculations at an unprecedented speed. Quantum computing is not just about speed, though. It's about solving problems that are too complex for traditional computers. It's about understanding the universe at its most fundamental level. It's about imagining new materials, new drugs, new solutions to age-old problems. And the best part? This isn't just theoretical. Quantum computers exist today, and they're only getting more powerful. Companies like IBM and Google are pioneering this technology, and the race is on to build the first truly practical quantum computer. Quantum computing is not just a concept. It's a reality that's changing the face of technology. Now that we understand AI and quantum computing, what happens when we combine these two revolutionary technologies? Imagine a world where machines can learn and evolve at an unprecedented speed. This is the potential of quantum computing when applied to artificial intelligence. Traditional computers use bits which can be either ones or zeros. But quantum computers use quantum bits, or qubits, which can be both 1 and 0 at the same time. This means they can process vast amounts of data simultaneously, potentially accelerating machine learning processes to unimaginable speeds. Consider the impact on fields such as cryptography. Today, encryption algorithms rely on the computational difficulty of factoring large numbers into primes. But quantum computers could solve these problems more efficiently, causing a seismic shift in the world of information security. But it's not just about breaking codes. Quantum computing could also help create new, more secure cryptographic systems, enhancing our digital security in the quantum era. Think about the implications for climate modeling. Our current models are limited by the computational power needed to simulate complex systems. But with quantum computing, we could create more accurate models, helping us understand and tackle climate change more effectively. And then there's the potential for drug discovery. Simulating molecular interactions is a complex task, even for the most powerful supercomputers. But quantum computers with their ability to handle complex calculations could revolutionize this field. This could lead to the discovery of new drugs, potentially saving millions of lives. But let's not forget, we're still at the very early stages of this fusion. We've yet to overcome significant technical challenges. Quantum computers are still largely theoretical, and AI is still learning to harness their potential power. But the possibilities are truly mind-boggling. We are at the dawn of a new era where AI and quantum computing together can unlock potentials we never imagined. Stay tuned for this exciting journey.